2021 experiment conducted with a Large Hadron Collider, an unexpected result emerged, showing signs of a new force or a new particle existing. Most of us already know that all the force effects we see in daily life can be summarized into four major categories, including the strong interaction, the weak interaction, electromagnetic force, and gravitational force. The strong interaction in QCD holds most normal matter together because it binds quarks into hadrons like protons and neutrons. Additionally, the strong force binds these neutrons and protons to form atomic nuclei. Most of the mass of a typical proton or neutron results from the energy of the strong force. The weak interaction is responsible for radioactive decay in both subatomic particles and fission reactions. The electromagnetic force is a form of physical interaction that occurs between electrically charged particles. It acts between charged particles and is a combination of all magnetic and electric forces. The electromagnetic force can be attractive or repulsive. Gravity is a phenomenon where all objects with mass or energy, including planets, stars, galaxies, and even light, are attracted to each other. On Earth, gravity gives weight to objects, and the Moon's gravity causes tides. Gravity is also the force that causes the initial gaseous matter in the universe to coalesce and form stars, and causes stars to gather into galaxies. Thus, gravity is responsible for many large-scale structures in the universe. In other words, gravity is the law that dictates what objects with mass or energy must do. For a long time, science has believed that the universe is not that simple. And as if to prove this well-founded suspicion, physicists have just found signs indicating that a fifth fundamental force of nature exists. From a laboratory near Chicago, scientists have made a new breakthrough. The four fundamental forces that govern all objects and particles in the universe determine how they interact with each other. However, there are still interactions and movements that we cannot explain with only these four limited concepts. The UK Science and Technology Facilities Council says the new experiment provides strong evidence for the existence of a new subatomic particle or new force. However, results from the Muon G2 experiments are still consistent with this new observation. Currently, the chance of a statistical fluke is 1 in 40,000, equivalent to a confidence level of 4.1 sigma. At the 5 sigma level, where the chance of a fluke is only 1 in 3.5 million, the finding would be officially recognized as a discovery. According to Professor Mark Lancaster, the British lead researcher who spoke to the BBC, we found that many interactions of muons do not match the traditional physics model. And researchers at the University of Manchester added that this is clearly an interesting observation because it could lead to a new future where we find new physical laws, new particles, and forces we have never known. This discovery is one of many promising results from particle physics experiments conducted in the US, Japan, and most recently at the Large Hadron Collider on the Swiss-French border. According to Professor Ben Alanak, an expert from the University of Cambridge who was not involved in the new study, he commented, "My spider sense is tingling. It tells me this will be a breakthrough discovery. Sleep because I." In the experiment conducted at the Fermi National Accelerator Laboratory in Illinois, USA, researchers searched for new elements of physics by studying the behavior of subatomic particles called muons. In the universe, there exist particles smaller than atoms, which are the tiny building blocks of reality. Among them, some particles are composed of even smaller matter, but there are also particles that cannot be broken down into smaller components. They are called fundamental particles. The muon is one of those fundamental elements. They also have similarities to electrons but are 200 times heavier. The muon is an unstable particle that exists for only a fraction of a second. Muons were discovered during the study of cosmic rays by Carl Anderson in 1936. They were discovered by studying how particles in cosmic rays bend in an electromagnetic field. Anderson noticed that some particles bent less sharply than electrons, meaning they must be heavier particles, and thus harder to deflect from their original path of the same magnetic field strength. Most naturally occurring muons happen when pions, particles created in the interaction of cosmic rays with atmospheric particles, decay. Pions decay into muons and neutrinos. Researchers conducted a muon G2 experiment by making the particles fly in a 14-meter circular ring, then placing the entire ring in a magnetic field. According to the known laws of physics, which are the components of the fundamental physics model, muons should wobble at certain rates. Yet scientists found that muons wobbled faster than normal, very likely due to another force acting on these tiny fundamental particles. No one knows what could cause muons to react this way. Theoretical physicists believe in another possibility besides a fifth fundamental force, that muons were influenced by other unknown subatomic particles. Currently, there are two candidates for this role, the leptoquark and the Z boson, also known as the Z-prime boson. Leptoquarks are a hypothesis in particle physics, proposing the existence of new elementary particles that combine the properties of leptons and quarks. Leptoquarks are predicted to be able to interact with leptons and quarks, meaning they can convert between leptons and quarks in particle reactions. This could explain some phenomena observed in experiments that cannot be explained by the standard model. Physicists working at the Large Hadron Collider have also had an unexpected research result. Their experiment suggests the possible existence of new particles or new forces, and we're getting closer to the threshold of discovering them. According to Professor Sumit Desai from Imperial College London, who collaborates with a team conducting the experiment at the Large Hadron Collider, the current goal is to try to create a test to prove this is truly a new discovery. We will need more data, more measurements, and hope to soon have evidence showing the effect on muon particles is real. A fifth fundamental force could explain many puzzles that are still puzzling researchers. For example, as in the journey to discover dark energy, the thing causing the universe to expand in all directions at an extremely high speed. Many researchers believe that is precisely the fifth fundamental force we do not yet have a formula to describe. These discoveries have the potential to rewrite current physics textbooks, finding new mathematical concepts to explain this vast and mysterious universe. Please subscribe to the Hidden_Realms channel to see the latest videos.